If you've used Krea2, you've probably noticed something very contradictory about it. Its realism, cinematic feeling, and details are all very strong, but it has one major problem: it doesn't have a stable, easy-to-use reference image generation method. If we want the same character to appear on the street today, in a bookstore tomorrow, and in the snow the day after tomorrow, while keeping the entire face consistent, relying only on prompts is probably not going to be easy. So if we want to achieve an effect like this, we have to train a LoRA for Krea2. Let's take a look at some of the results below. In these groups of images and videos, the character is the same virtual character. She can appear at a rainy street corner, by the sea, in a flower market, in a bookstore, in the snow, in the desert, and in a bar. More importantly, she is not only stable in close-up shots. Even when we pulled the whole view out into a large 16:9 scene, she can still be clearly recognized. So if you really want to take advantage of Krea2's generation ability, especially for stable people, stable characters, and stable cover visuals, LoRA training is basically unavoidable. In this video, we'll start from zero and walk through the complete process of training a Krea2 LoRA. We'll prepare a character dataset from scratch. Use AI Toolkit to train a Krea2 character LoRA. And after training, we'll use Krea2 Turbo to verify the result. There are 5 key points here. First, how do we make the dataset? Second, how do we set up the training environment in a more convenient way? Third, how do we choose the training tool? Should we use AI Toolkit or Musubi Tuner? Fourth, which parameters in the training task actually matter? And fifth, after training, we can't just look at one good image. We need to systematically test identity consistency, generalization, ability, and failure cases to make the environment easier for everyone to use. I made a Krea2 LoRA training image on Compshare. Compshare is an online cloud platform I use very often. I think in terms of GPU quality, overall stability, and pricing, it's relatively suitable. In this image, the training environment, model files, and the dataset used in this tutorial are already prepared. You can directly create an instance and enter the training process. Alright, next let's look at the dataset. LoRA training will definitely run into character, IP, and copyright issues. So this time, we're training a virtual character. There are many ways to create a virtual character. My method is to first create a character sheet, which is a character reference board or character design sheet. We first lock down the overall style of the face shape, hairstyle, temperament, age impression, and clothing. Once we have this character sheet, the dataset generated afterward won't completely drift away. Then we open ChatGPT's image generation feature. We use the character sheet above as a reference and continue generating character images in different scenes, different angles, different lighting, and different compositions. The most important sentence here is this: the dataset needs to be both unified and varied. If all the images use the same studio angle, the same expression, the same hairstyle, and the same background, then yes, the model will remember this person, but it will also remember the background, expression, and hairstyle together. So everyone must pay attention to character diversity. Of course, if you want one aspect of the character to stay fixed, you can keep that consistent in the dataset. For example, in my dataset, I keep the hairstyle consistent. For a first training run, I recommend preparing 20 to 50 images. The final effect we want is that the person's identity stays consistent, while the scene, lighting, composition, and expression are as diverse as possible. The organization format is quite simple. We name the images with numbers, and each image has a matching text file with the same name. It is a TXT file. What do we write inside the text file? We write the prompt. Here, I still use the habit from my previous LoRA training. I use Sendi as the trigger word, but I still want to remind everyone, for large models like this, a trigger word is not mandatory. Next, let's create the instance. For the GPU, I still recommend using an RTX 4090 with 24 GB of VRAM. After the instance starts, wait about 2 minutes. The image will automatically start AI Toolkit. Then you can enter the interface through the public IP plus port 8675. After entering, I suggest setting the Hugging Face token first. The setup method is also very simple. Go to Hugging Face, apply for a token, and paste it here. Then we create a new dataset and upload the images we prepared earlier together with the matching text files. Make sure to check whether each image corresponds correctly to its prompt. Next is the training task. There are many parameters in the interface, but we do have a template. In fact, for most settings, you can just follow the defaults. Here, I'll point out a few things you need to pay attention to. First, the training model must be set to Krea2, but when we verify the result later, we use Krea2 Turbo. Let me briefly explain this in AI Toolkit. There are two Krea2 training models. One is raw and the other is turbo. According to the official explanation, the turbo model cannot be used as the training base, but the author of AI Toolkit added an optimizer, or you could call it an adapter, so that the Krea2 turbo model can also generate LoRAs. However, he also mentioned that this generation method is not very stable. The only advantage is that it is faster. So here, we still choose the Krea2 raw model as the base model for training. Third, for the dataset, you must select the dataset we just uploaded. As for training steps, based on my testing, Krea2 converges relatively slowly, so I suggest setting it somewhere between 3,000 and 5,000 steps. Basically, at 3,000 steps, you can already get a pretty good result. We still save a sample every 250 steps. After training starts, don't stare at the progress bar the whole time. What really matters is the samples. The system will generate a batch of images every 250 steps based on the sampling prompts we set. In the early stage, it probably won't look very similar. Usually, in the later stage, for example, after 1,500 steps, you'll notice that the face shape, eyes, hairstyle, and temperament slowly start to appear. After training is complete, we usually get multiple save checkpoints, or multiple LoRAs. Generally, I will download the last one, because visual models can also have overfitting issues. After training, we must verify the result. As I mentioned earlier, we train with the raw model, but we verify with the turbo model. In a Compshare workflow, we can load the Krea2 Turbo model. Then load the LoRA we just trained. In the prompt, we write the trigger word sendi. For the LoRA strength, I suggest setting it between 0.7 and 0.9. In my tests, I use 0.85. If the value is too low, the LoRA strength won't come through, and the character won't look similar enough. If it is too high, duplicate characters may appear in complex scenes. Finally, let's talk about how to test this type of LoRA. After training, you can simply run a few quick tests. But if you want to do a complete test, I recommend testing two categories. The first category is 3 to 4 portrait tests. We mainly look at identity stability, reproduction of the trained style, lighting variation, and composition generalization. Based on my testing front view, 3/4 side face, close-up, and half-body shots are all relatively stable. Scenes that are close to our training data, such as rainy street corners, seaside locations, rooftops, and fountains, perform the best. Greenhouses, bookstores, flower markets, art galleries, traditional courtyards, and lakeside scenes also basically work in terms of lighting, low-key studio photography, high-key commercial portraits, neon rainy nights, and black and white portraits can all change according to the prompt. The second category is large scene testing using 16:9. I think this is more valuable because for many character LoRAs, their stability only holds in close-up situations. Once you pull out into a large scene, problems may appear, but you'll notice that this version of the LoRA still performs very well in large scenes, such as running through a rainy night, cycling through an alley, and standing in a rooftop storm. So after this LoRA is trained, it is not only useful as a portrait LoRA, it can also be used for covers, case images, and even large scene character showcases. The problems are also quite clear, because during training, I intentionally emphasize the character's face and hairstyle. You'll notice that her emotional range is relatively narrow. In close-up images, she shows more smiles, calm expressions, and a clean, gentle look. Other expressions were not trained especially well. Another issue is that when we encounter complex glass reflections or laboratory scenes, duplicate figures may appear. So when writing prompts, make sure to include something like no duplicate people. Also, large movements are usable, but some small details may require multiple draws to get a better result. So my recommended workflow is this. First, make a clear portrait character sheet, then generate 20 to 50 high-quality training images. Make sure the images and prompts correspond one by one. Beginners should first use AI Toolkit to get the whole process running. After you become more familiar with it, you can try Musubi Tuner. For training steps, use at least 1,500 steps. I think 3,000 steps gives a pretty good result. Many people who train this model share the same feeling: it converges more slowly than QWN image. After training, make sure to test it with the Turbo model. And when testing, we need to test both consistency and generalization ability. So if you want to fully unlock the strengths of Krea2, you need to train a LoRA for it. All right, that's all for today. Follow me and become someone who truly understands AI.